おはようございます。こんにち
先生、
は。
こんにちは。よろしくお願いします。ありがとう。ありがとうございます。
こちらこそ。
元気ですか？
はい。はい。月曜日いつもお忙しいなんで、ありがとうございます。
難しい。いえ、とんでもないです。ありがとうございます。
実は僕、明日の夜、札幌の方に行きます。北海道情報大学かな。
何日行くんですか
5日間くらいです。明日出て、で、28について、で、400くらいかな。
なるほど。台風が来てるので、
おお
台風、
いつでか、明日
ちょっと待ってください。
明日って。
台風。
うわ北海道までまだ行って。
北海道はまだ大丈夫だけど、飛行機が
うわ
こう来るのかな飛行機。大丈夫
だと、中国から。
こうですかね。だから遅れるかもしれない。
はい、
大変。
わかりました。うわちょうど。今回、台風大きいですか？
大きい。はい。
今日は、また同じ毎年、ありがとうございます。セミナー。
ありがとうございます。どんどん大丈夫です。
どんどん学生さん来てますんで、学
はい。
生と多分チャットチャイ先生の学生さんも来てます。
そうですか。なるほど。
Nima, he is the PhD student of my laboratory.
Very nice. Nice to meet you. No. Nice to meet you. How are you?
Yeah, fine. Thank you very much. Yeah, I'm so excited to hear your presentation.
Thank you very much.
Sure.
Not so serious because he is a big professor of plasma.
Very nice. Yes.
He can explain very difficult thing to easy to understand.
Good. Very nice.
先生、あと10分くらい。
OK。はい、大丈夫。はい、大丈夫。OK。
今、天気どうですか？
天気は曇りですね。
涼しい？
涼しい。
今、日本は夏休みかな？
夏休みです。はい、夏休み。
あまり暑くない、岩手は。
暑くないですね。そうですね。タイはどのぐらいですか？
今、なんていう、梅雨雨が多いです。ほとんど毎日。雨多いです。ほとんど毎日です。
11月は根検します。
11月ですか？根検で
各回。
予定は本県だけですか？
本県、チェンマイにも行きます。
チェンマイ。おお
チェンマイ。
11月。
11月。
おーちょうどいい。多分もう、その時もう雨がないだと思う。
雨ないですか？
だと思う。11月の何日くらい？
最後ですね。
お
20 27、28、
はい。
29、30ですね。
高いですか？
各回です。はい。
おおキーノートスピーカ
インバイト。そうですね、インバイト。
ー、インバイトスピーカー。
マレーシアって遠いですか？
はい。マレーシア。
マレーシアは、はい、クアランプール。クアランプール。
飛行機で、バンコクから飛行機で多分1時間半くらいだと思う。
1時間半。1時間半。そん
飛行機
な近い。
で近いです。京都と北海道みたいな感じ。
あ、2時間ぐらい。
2時間。
2時間。2時間。なるほど。マレーシアに11月行くので、
おお。え、マレーシア11月と台湾11月も。
の末。マレーシアは11月の最初の。
おお、頭くらい。
そうですね。
11月の終わりくらいはちょうど多分、タイのベストシーズンの
あ、
入るところ。
そうですか。
入るところ。
なるほど
入るところ。あれが多いです。ビアガーデン。
あ、そう。クアラランプール。いいですね。いや、バンコクに寄ってもいいかなと思って。
おお。頭くらいですか11月の
11月の頭ですね。
一泊くらいどうですか？
いいかもしれないですね。ちょっと考えます。考えます。
11月頭くらいだったら、まあ、ちょっと、あと、まあ、1日、2日ですか？
5、6、7、
OK。
6、7、8、6、7、8です。
OK、OK。ちょうどいいかもしれないです。
ちょっとわからない。わからないけども。はい。
はい。もし時間があれば。
はい、そうですね。今日はみんなオンライン。
オンラインです。ほとんど
ありました。
学生さん、ほとんど学生さんです。ですね。
なるほどですね。わかりました。
でも、あまり厳しくではないですけれども。
あ、いえいえ。
学生さん、
はい。
M1 くらいだと思う。
M1。OK、OK。
M1
了解です。
ばっかりなんで、今、ちょうど、なんというか、中間くらいかな。
なるほどですね。
先生、今、研究室ですか？
ケースです。はい。
夏休みもだいたいあと
まだ
少し。
夏休み中ですね。
ありがとうございます、今日。
いえ、こちらこそありがとうございます。
先生のスライドをシェアをしてみます。
ちょっと待ってですか。ちょっと待ってくださいね。
はい。
タイに行ったのっていつでしたっけ？私が行ったのは。
おお。あんまり覚
覚えてない。
ちょっと、多分もう半年くらい。
私前くらいですよね。
多分、
月とか2月か。
あ、そうか。4ヶ月前。
そうですね。
5月くらい。
5月ぐらい。
5月くらいだと思う。
5月。
チャットサイズ先生と、その時に。5月の真ん中くらいかなと思う。
ね、そうですね。
チャットチャイ先生と。その時僕中国の方に行ってたので、
そうですね、そうですね。
会えなかった。ごめんなさい。
そうです。いや、いえ、大丈夫です。
先生、最近、学生さん何人くらい研究室にいますか？
24人、25人。はい。
ほとんど M1、M2 とか。
4年生バチェラー
4
4と M1 と M2 ですね。
半分くらい半分くらい、半分くらい4年生ですか？
そうですね。はい。す
結構
ごい多い。多いですね。はい。
多い。結構多い。大人気かな。
まあそうです。
大人気かな。と、かっこいいからか
いやいや、そうですね。
な。最近若い人は、研究室選ぶのは、ちょっといろいろ、なんというか、コンディションがありまして。まあもちろん、一つが、研究のテーマとか、まあもう一つの2番目が多分かっこいいとか。
そうです。ありがとう。ありがとうございます。
もう14人くらい、まあ大体10何人くらいだと思う。今日はゼミナー入る人は。
わかりました。これは講義ではなくて、ただのレクチャー。
前期です。前期。
講義。講義。レクチャー。
前期。そうです。ゼミナーの。今、タイでは前期に入ってる、初めて。
なるほど。じゃあ、これは講義になりますね。
そうです。で、タイのシステムはちょっと違う。日本
なるほど。
タイの夏は4月なんで、
うんうん。
で4月終わってから、なんというか夏休み終わってから、まあ、今、前期入ったばかりなんで。
わかりました。これ、講義の名前を教えてもらえますか？
エネルギー and Materials ゼミナーかな。
Energy and Material Seminar
え
and Material Seminar for for master students.
Master and PhD student.
Ah, okay.
OK、先生、始まります。
はい、大丈夫です。
はい、はい、どうぞ。シェアし、スライドをシェアしてください。
Okay. はい、Yes. 見えてますか？大丈夫ですか？
OK です、先生。OK ขอบคุณทุกท่านครับก็วันนี้เป็นอีกหนึ่งวันนะครับที่จะได้รับเกียรติอย่างยิ่งนะครับจากทาคาชิเซนเซนะจากอิวาเตะ University นะครับท่านมีความเชี่ยวชาญทางด้าน High Voltage แล้วก็ Plasma นะครับแล้วก็มามีการปรับประยุกต์ใช้ที่เกี่ยวข้องกับหลายๆงานมากๆเลยไม่ว่าจะเป็นงานทางด้านเกษตรกรรมหรือว่างานทางด้านอื่นๆนะครับลองฟังดูเผื่อเป็นแนวทางในการเอาไปปรับประยุกต์ใช้กับงานวิจัยของตัวท่านเองนะครับซึ่งจริงๆแล้วบางคนอาจจะฟังว่าเป็นทางด้านไฟฟ้าซะทีเดียวนะครับแต่ผมคิดว่ามันถ้าท่านทำอะไรอยู่แล้วนะครับถ้าเอาตัวนี้ไปเสริมอาจจะช่วยให้ งานท่านมีประสิทธิภาพเพิ่มขึ้นได้ดีขึ้นนะครับลองฟังเป็นความรู้แล้วก็เผื่อเห็นรูปเห็นแนวทางในการปรับประยุกต์ใช้นะครับ Today we have Takahashi Sensei from IWATE University. So I would like to say on behalf of the Faculty of Engineering and Energy and Materials course, we would like to say thank you very much for his presentation for today and every year. every year. So today he will present about the topic of environmental and agricultural application of high voltage at plasma. So please, Sensei, not so serious because today we have many students.
Okay. So Koppen Cup, Sorapon, Koppen Cup, Saudi Club, and Chu Takahashi Cup. Okay. Yeah, so nice to meet everybody. So my name is Takahashi from IWATE University, and thank you very much for Sorapon Sensei for organizing this lecture for me. Okay, so in this lecture, so I have a presentation regarding to as this title, so environmental and agriculture applications of high voltage electrostatic and plasma. So I'm one of the associate professor in the electrical engineering course in IWATE University, and my major is electrical engineering actually, and also the plasma engineering, and my research topic is these applications for the plasma and the high voltages. So in this presentation, I will have a brief introduction about this, and I hope you have interested in our research topics. But just before that, so let me have introduction by myself as ice breaking. Okay, can you see that? Okay, so my name is Takahashi. Takahashi is a family name, and yes, first name is Katsuyuki, and I'm again, so I'm an associate professor in electrical, electronic, and communication course in Faculty of Science and Engineering in IWATE University. So maybe some people know where is IWATE, but IWATE is one of the minor city in Japan. So let me have an introduction about what is IWATE, and also maybe many guys, you know, the map of this shape of the Japan as like this one. And yes, Tokyo is here, the capital city of the Japan. And also many people right know the Kyoto here is very historical place, and you can see the very beautiful historical buildings and everything. And Iwate is around here, one of the northern parts of the area of this Japan, as you can see here. And okay, so I'm right now I'm in here, so Iwate Prefecture. And okay, so actually, so I'm an associate professor in university, but I am one of the master of the Japanese tea ceremony, traditional tea ceremony like this one. Maybe many guys know the matcha, green tea. Do you know? Yes, maybe matcha. Maybe everybody likes this. I hope that. And I'm one of the master of the Japanese tea ceremony. So when you come to my university, my prefecture, so I can serve you this matcha green tea with a traditional manner. And also, so my hobby. So usually, so in my day off, so I go to the outside to take a photo in the nature, and sometimes I have a exhibition like this one, and some guys buy my photograph like this type arts like that. Okay, so let me move to the introduction of the Iwate. Sorry, so this is sorry. So okay, so ignore this one because this presentation was used in the McMaster University in the Canada last week. So sorry, so I missed to change this photo, this one. But maybe you can reach to the Tokyo within the 6 hours from the Bangkok, I think. And after arriving at Tokyo, Narita Airport, you can take a Shinkansen, Paris train, and you can reach to the Iwate with around 2.5 hours from the Tokyo. They're very convenient. And Iwate is here. And actually, so population of the Iwate is not so big, around 1.3 million. But the area of this prefecture is the largest in the main island, Honshu Island in the Japan, excepting Hokkaido. Hokkaido is very, very large. Maybe some guys know where is Hokkaido. And the Sorapon sensei will go to the Hokkaido tomorrow. Tomorrow, I'm not sure. Okay, actually, so Hokkaido is a very, very big island in Japan. And yes, so this, yes, just because yes, the population ratio is very lowest in Japan, in Iwate. So there are so many, lots of mountains and forests. So that means that yes, population of the animals in this area is much higher than human beings. So there are so many animals in our prefecture. So that's why agriculture application is much important, very, very important in this Iwate prefecture. Okay, so let me have an introduction about the Morioka. Morioka is the capital city of the Iwate prefecture. And yes, so our university, Iwate University, is located as a Morioka city. And so Morioka city is very, very famous for the foreign people in these days, because this city was introduced as 15 places should go in 2023 for the every world. And this one is introduced in the New York Times. Yes, so Morioka was introduced as like these places, and the second place in the world. The first one is London, and Morioka is next. So in this case, so in this time, so we have many foreign guests from foreign countries in the Morioka city like this. And you can see very beautiful nature scene in Morioka in the spring. So we can see the very lots of the sakura cherry blossoms like this. And the Japanese likes to drink under the sakura tree like this in springtime. And you can see like these very beautiful lakes and the very beautiful mountains. Actually, so this mountain is volcano, and you can enjoy the onsen, hot spring, and also beer after the getting hot spring, getting bath. And autumn season, so you can see very beautiful autumn leaves. Every leaf changes color from the green to red, like this one, and also very beautiful flowers like that. And also there are many traditional cultures, and you can face the very traditional festival like this one. And also I'll never forget the food. There we have very, very fresh food, like wild vegetables with a tempura like this one, and also the sushi, like very, very fresh sushi like this. And so like a beef and the pork you can eat like this, and the real shabu shabu like this one, you can enjoy this very much. And also with this, the rice wine, Japanese sake, we say. Japanese sake is very, very famous in this area. And you can enjoy this taste with these very delicious foods. Okay, maybe, so if you have a chance to come prefecture, please let me know. I can take you everything. Okay, so and you can enjoy the Iwate, the Morioka. And please, interested to visit our prefecture. Okay, so that is all for the introduction of the Iwate. Okay, so right now, so move to the academic side. Okay, so my major is electrical engineering, and I can generate a lot of plasma. Is one of the topic of this presentation. And like this one, so we can generate like atmospheric plasma discharges like this one. And this last one is like a gas phase like this one. And this one is a plasma contacted to water like this. You can generate the plasma on the surface of the water and generate the plasma underwater directly. And also we can generate the vacuum plasma, low pressure plasma like this one. But actually, so in this presentation, we focus plasma generated under atmospheric pressure. Okay, so this is my research topic in our research our laboratory, and actually, so our major is electrical engineering. So we can design the own high voltage pulse generator like this one. I will introduce about that later. And using this, so we can generate the pulse electric field and a lot of the plasma, atmospheric plasma, like this one. And using that, so we expand the application topic using this one for the every various kinds of fields. For example, so environmental and like ecosystem and like agriculture applications. Okay, so in this presentation, in this lecture, so I will introduce about these applications. Okay, so this is one of the one of the examples of the application for the agriculture of the plasma, like this one, and I will explain detail later. Okay, so that is a brief introduction and the first step. Okay, so maybe in this lecture, maybe how many guys do you use a plasma? Maybe a few professors, a few students use a plasma. So maybe let me have an introduction of the what is a plasma first. Maybe it is required, I think, I guess. But okay, so maybe some people knows what is a plasma, but please learn it again, please. Okay, so the plasma is one of the states of matter. Already you know the three states of the matter. At first, a solid, and when increase the temperature, it becomes liquid. Then, so it will be gas phase. When you increase the temperature of the gas phase, so as the next state of matter, the gas could be changed to plasma, like this one. Okay, so what is the plasma? Yes, so in the gas phase, so gas phase consists of the neutral atoms and the neutral molecules, like nitrogen molecules and the oxygen molecules. It is okay. But in the plasma, so inside of plasma, so electrons, a lot of electrons and a lot of the ions and atomics are very, mixed and with a very, very high concentration. So this condition is a plasma, called plasma. Actually, so there are many methods to generate plasma, like laser plasma or like a heat plasma and everything. But also the solar on the sky, on the cosmic is also the plasma. But when we generate the plasma, we use a high voltage, like several thousand volts, like this, utilizing the high electric fields. Okay, so how do I generate it? Okay, at first we put the electrodes, high voltage electrodes, like a needle or wire or something like that, and we put the grounded electrodes, zero potential ground electrodes. So so in this case, so we apply the high voltage to the high voltage electrodes. Electric fields is generated between these electrodes. Yes, so electric fields is expressed as these equations. Okay, maybe it is very fundamental for the physics. Maybe everyone learned about this one in the high school, the lecture of the physics in high school. Okay, and when we put this here electron, so this electron is accelerated by the Coulomb force, F equal QE. The Q is a charge over this electron, and this electron gives a force by this Coulomb force, and it can be accelerated. Okay, so it's accelerated, and so when it's sufficiently high speed, that means that it has a high energy. So when this electron, so this electron gives the energy by the acceleration by this Coulomb force, and this electron has sufficient high energy, large energy, and this electron is impact to the neutral molecule like nitrogen, like this one. And in this case, so ionization, that means yes, electron is go outside from the neutral molecules like this one, and the new electron is generated. This phenomenon is called ionization, right? And here, so this electron generates a new electron, and this electron generates also ions, plus ions. And these electrons can be accelerated again by the electric field and then impact the other molecule. And this repeating these processes, so number of electrons and ions are increases. and so many electrons and ions are generated. And as I introduced what is the plasma in the previous slide, yes, so this condition is so many electrons and ions. So this condition is called plasma. Okay, and the plasma has emits like very strong light like this one. Okay, so and then so why we use plasma? The reason is the plasma can generate the active species radicals such as hydroxyl radicals produced by the plasma by some chemical reactions. Okay, for example, so when electron is impacted to the oxygen molecule, so oxygen molecule dissociated to the atomic oxygen like this one. In the other case, so when electrons impact the H2O, water molecules is dissociated to the OH and the H radicals. Because these species, these radicals has a lack of electron. That means that they want to pull the electron from the other molecules because we need more electrons. So that means this chemical reaction called oxidation. Okay, so that means that yes, these radicals has a very high oxidation potential in this case. And then, so that's why, so we use these radicals for to induce oxidation reactions. And so in this plasma, so these radicals can be generated by only electrical energy. The plasma doesn't need the chemical reagent or some other reactions. So that means the plasma can generate this one with only the electrical energy. That means when you need these radicals, okay, so you can push the switch on, turn on. That is okay. And you can control the voltage or like a frequency, only that. So in this case, we can get these radicals on demand, and very easy to control the flux and the dose amount of dose and everything. And this is one of the example induced by the plasma. Chemical reactions induced by plasma like this one. Actually, so this plasma is a very, how to say, the chemical reactions induced by the plasma is very, very complex. But we can what happened here, and we can control we can control the chemical reactions by everything. Okay, usually, so this plasma is produced in the low pressure, like a several Pascal or something like that. And the plasma, like this one, can be used for the semiconductor process in the world, in this case. But because it's in the low pressure, so it's very easy to generate the plasma. But you know that, so my research topic is environmental agricultural applications. So in this case, so yes, so the target is like a human being or animals and the living cells or living vegetables like this. But in this case, so these samples cannot go inside the vacuum chamber. When we go inside, so blood and water, everyone is evaporated. So in this case, so in these applications, so we need atmospheric plasma, not low pressure plasma. But this is a very important topic, but a little bit complicated. Okay, so when we use this graph shows the horizontal shows the pressure, and the vertical shows the temperature, right? And this curve shows the electron temperature. And that means the electron energy, and this graph shows the gas temperature, right? Okay, so when we generate the plasma in low pressure, so yes, we can get the very high electron temperature, high electron energy. It's okay, and but also the gas temperature is very low, like a room temperature, like this one. So in this case, so because the plasma is initiated by the electron impact, and the radicals can be generated by this electron impact. And this electron impact requires a high energy, high electron energy. So in this case, so the low temperature, low pressure, so we can get the very high efficiency for the radical production. It is okay, very nice. But when we increase the pressure, like atmospheric pressure, like around here, yes, actually, so the electron impact is as the frequency of electron impact increases, and the energy of electron can be transferred to the molecule, vibration of the molecule or rotation of the molecule. In this case, so electron temperature decreases, electron energy decreases, and gas temperature increases, like several thousand Kelvin, 7,000 Celsius degree, like this. Very super high temperature, very hot. So in this case, like in this case, so this plasma like a thunder, very low, large current and very hot. Okay, so in this hot plasma can be used for the melting or something like that, but it is very low efficiency for the radical production. So in this case, so in also in the atmospheric pressure, so we can get we want to get the high electron energy and a low gas pressure, low gas temperature, like this. Okay, so to realize that, we use a nanosecond pulse discharges to generate the low temperature plasma. And then this low temperature plasma called the non-thermal plasma. In this case, only electron temperature is high. That means the electron energy is high, but the gas temperature is low, like a room temperature. And in this condition, so this non-thermal plasma can contribute to highly efficient chemical species productions. It is very good for our applications for the environment and agriculture. So in this case, why we use a nanosecond pulse? So yes, this is one of the example. Okay, you can see here. So here is like high voltage electrode, and on the opposite side is grounded electrode. Okay, so we apply the high voltage to this high voltage electrodes. Yeah, so plasma can generate it near high voltage electrode is here. And actually, so in this case, so the condition of the plasma is non-thermal. The electron energy is very high. But this plasma is propagated towards to the grounded electrode like this way. And this propagation velocity of this plasma is around millimeter per nanosecond, very high. But it's okay. But when this plasma connected between the high voltage and grounded electrodes, so that these electrodes can be bridged, shortened by this plasma. Actually, so this plasma is conducted. That means the electron can go through. That means that when these electrodes can be shortened, yes, large current flow through this plasma. And the temperature of the plasma can be heated up. So after that, so this plasma is transited to the thermal conditions from non-thermal conditions. We want to avoid this transition here. Okay, so to avoid this thermal transition, so we want to only these conditions. In this case, so to avoid that, so we can cut off the voltage just before the shorten, just with the plasma shortening before the electrodes. So that means, and so yes, the propagation velocity of the discharges is in order of nanosecond. So that means, so that's why, so we use a nanosecond pulse voltage to generate these non-thermal plasmas. Okay. And here to achieve that, so we use a pulse power technologies. Use. Okay. So this is one of the methods to generate high power. High voltage. High power means high voltage and large current by compressing electrical energy in the nanosecond for some power as a pulse voltages. Okay, in this technology, so we can charge it up with low power in some capacitor or something like that. And after charging, when the switch is operated, so this energy is emitted, released as a pulse conditions. with like a nanosecond within the nanoseconds to microsecond. Okay, so this is one of the example. Okay, when you charge the energy with a 100 watt during 10 seconds, 100 watts is very, very low, like this personal computer or something like this. Okay, so when you charge energy with a 100 watt during 10 seconds, and you use compressed this energy and emit it only during the 10 nanoseconds. So imagine ideal. So in this case, ideal output power is 100 gigawatt. 100 gigawatt. So very, very big. So 100 gigawatt is is the maximum power generated in Japan. So that means that you can get this very, very big electrical power using only 100 watt using these power technologies. It's a very good one. And using this, you can generate a like a nanosecond pulse and with very, very high electrical energy. And it's enough to generate the plasma, because the plasma requires a very, very high electric power to generate them. And actually, so this pulse power techniques can be used, was used for the military use, like a railgun or like a laser weapon system in the military, and also like a plasma fusion like this, or accelerator like this. But these techniques, these facilities is very, very large and super high power and so expensive. So in this case, the farmers cannot buy these very, very big facilities. So in our laboratory, so actually, so this technique is very, very, how to say, very interesting, but it cannot be used for the new applications for the agriculture and the food and environment. So in our laboratory, so we try to make system compact and small with like these specifications. Okay, so because my major is like electrical engineering, so we can design the like this this electric circuit model, and using this knowledge, so we design we build the own pulse generator like this one. And for example, so we in this sense we use a SiC MOSFET semiconductor devices. And using these techniques, so we can generate like we can produce like a palm size, very, very small size plasma devices can be used by anyone and anywhere. Like this, very, very compact, very super nice. Right? Okay, so using this plasma techniques, so we apply these plasmas for the food recycling. For example, so we use this plasma and hypoxic technique for the food production, and like a food processing, and the distribution and the storage, and also dining. And after that, so the food waste is very, very important topic. But using this plasma technique for the treatment of the food wasting, and so this food waste to, and after plasma treatment, so this food waste can be utilized for the fertilizer of the food production. And then so actually, so we use plasma to establish like food recycling like that. Okay. Okay, so for example, so do you know lightning thunder like this one? And actually, so some people, maybe only few people know the Chinese character kanji, Japanese character like this one. But we in Japan, maybe we use a very complex character system, and we use like a kanji. Kanji is one of the Chinese character in Japan like this one. And this Chinese character shows lightning. This means we say this one is a kaminari. This one is one. And this character means this lightning. But this Chinese character is consisted of two Chinese character, upper part and the lower part. And the upper part means rain. And yes, so bottom part shows a rice field. And here, So this one is shows the inazuma. Inazuma means the sun, like this. And so inazuma, this part means a rice plant, and this part means a wife. That means the inazuma means a rice wife of rice, like this. So actually, so maybe this word is established in the over 1,000 years ago, but people in ancient era, everybody know the relationship between the sun and like rice or food production, like this. And you know that this sand condition of this sand, like this bright part, is a plasma, and also this plasma is generated by the very, very high voltage. So there's super big relation between the like food production, agriculture, and the plasma and high voltage. And this is one of the example for the using the high voltage for the food production in agriculture case, real agriculture. And here we use this high voltage to enhance and improves the mushroom production, like this. And we bring this high voltage generator to the mountainside like this, and we apply the high voltage to the uzun rock, like this, uzun rock, which the mushroom hypha is inoculated, like this. And when we apply the high voltage to the mushroom rock, like this one, okay, in this case, we can get a lot of mushroom from these mushroom rocks. Yes, this is one of the example that's introduced in the TP program. Sorry. Okay, this is without electric the voltage application, and this is a example. Yes, voltage application, after voltage application. As you can see here, so the mushroom can be produced by very quickly after electric field production. And actually, so we get the double production just as a voltage application. And that means, yes, so production, cropping yield and the mushroom production can be accelerated by, significantly accelerated by the voltage applications. And actually, so the mechanism of that is unclear still now, open questions still now. But maybe we expect that this pulse application can induce the gene expression after pulse generations, like this. But right now, so we conducted the experiment to check these mechanisms, like this one. And also, when we apply the electric field to the cell membrane, so on the cell membrane, so it's charged up by the electric field. On the surface of the cell membrane, it's charged up by applying the electric field generated by the voltage, by applying the voltage pulse. And here, so for example, the cell membrane surface of one side of the cell membrane is charged up the plus, and the other opposite side is charged up the minus. And here we have a plus and minus, and between them, the Coulomb force is applied to the cell membrane. And here, so when this charge gives the mechanical force to the cell membrane, and this cell membrane is broken when this force exceeds the mechanical strength of this membrane, and this cell membrane is broken down by this voltage applications. And for example, this technique can be used for the drying. So maybe in Thailand, there are so many dry foods, I think. And sometimes I enjoy the dry food from Thailand, like a mango or something like that, well, everything. And when we apply this electric field to the, like for example, so vegetable, this is the spinach. Yes, the surface of this material, cell membrane can be broken down and the pulse application can make a hole on the surface of the cell membrane like this one. And here, so inside of the cell, so there are so many H2O molecules. And in this case, so through these holes, this H2O molecule can go outside very easily. So that in this case, so the H2O go outside. That means that yes. So in this case, the pulse application makes these vegetables too easy to dry up. Okay, so this is one of the example. Okay, so this is a microscopic image of this leaf, and there are many cell membrane cell back like this one. And after pulse application, yes, the cell membrane is broken down like this one by the pulse applications. Maybe so the mechanism of dance is maybe so when we apply the pulse voltages, yes, holes are made on the surface of the cell membrane, and the enzyme it goes outside to the cell membrane, and this enzyme can contribute to the breakdown of the these chemical compounds, and then so this chemical compound is contributes to the bond of the cell bags, and this when this chemical structure is broken down, so yes, so this cell bag is separated like this. And as you can see here, yes, so this condition of the cell membrane is separated and broken down. And actually, so in this case, so we can get the double. That means that yes, so the time needs to dry up can be shortened by the double half, like this one. It doesn't mean the food drying time can be accelerated, very significantly accelerated by these techniques. So in this case, so when we apply the pulse voltage electrobeats to the vegetables, and then acceleration can as a drying process can be shortened. Time of the drying can be shortened. That means that yes, the heating is requires a lot of the energy, electrical energy, but this energy for the use in the drying can be saved by the electrobeats pulse applications. And also, we can use this technique for the useful extraction of useful components from fruits and vegetables, and we can break down the cell membrane back. Sorry. So this photogram shows a microscopic image of the grape skin. And okay, so you can enjoy the fruits of the grape. After that, the skin is wasted, but still now, still now, so yes, inside of the grape skin, so many useful components is remained. For example, so this one is a microscopic image of the grape, and you can see here, so this black part is a cell membrane. It contains a polyphenol inside the membrane like this. And when usually, so this extraction of these useful components is extracted by the chemical reagent, very toxic one. But in this case, so we can extract these useful components by the voltage applications. For example, yes, so this black part move to the outside of the skin, and in this case, we can extract this polyphenol from this grape skin very easily without chemical reagent and without heating up. So in this case, so we can use this technique for the very safe and non-thermal process, and it can be very useful. We believe. And so next is application of the plasma discharge. This like this one. Already I showed you. Now, for example, application of the gas discharges like this one, and already I show you that we can build this pulse generator like this one, and then it's inside of this. So this plasma reactor includes the pulse generator and plasma electrodes to generate plasma, and inside this, so that this very beautiful plasma can be generated. Yeah, and this plasma. Okay, so I will skip this one. Okay, so this plasma can be used for the one that is a dust fraction. Okay, so inside this box, this box, the dust is filled like this thing, and we put the high voltage electrode like this thing, and when we turn on, and the plasma discharges, okay, as you can see here, this dust can be collected very quickly like this one. And also, yes, so this plasma generates radicals like this one. Yes, so for example, so we use this phenomena for the application of the food preservation. For example, so do you know ethylene, C2H4? Ethylene can be released from the apple, or some. The apple is one of the most important, most famous fruits emitted ethylene with a high concentration in Japan. Okay, so for example, so these fruits emit ethylene a lot, but with this breeze, yes. Then when this ethylene and the other when approaches the other plant, other fruits, and when this fruit receives this ethylene, so this fruit is ripening, get aging. Okay, get aging. In this case, so the hardness of the fruit is softened, and then so the how to say so the taste can be lost. That means that yes, this fruit can be damaged by this ethylene. So it is very, very bad in the transportation and the storage conditions. Okay, so in this case, we use this plasma to eliminate this ethylene by these radical reactions like this one, with a very, very high speed reactions. And also, so as I show you that this plasma can correct the dust in the gas phase. So for example, like yes, this plasma generator can correct the fungi like this one. And when we use this one in the storage house in the fruits and vegetables, yes, we can get the fungi. And in this case, so we can avoid the fungi outbound on the surface of the fruits and vegetables. And already we developed this one for the practical use, and we like this size or like a desktop size, and we install the cell of the like this container. Only two devices is required for this 20-feet container, and we have a pilot test that this container is transported from the Kyushu in one of the port in the Japan to the Hong Kong port 2 times. And we can get a good result in this pilot test. And yes, so maybe this plasma techniques can be very useful for the fruits and vegetable preservations. And also, so we use this fan for the gas treatment for the chicken house like this one, because the chicken house is filled with a very odor, stink gas like ammonia and everything. And this ammonia can be eliminated by the plasma treatment very easily. And also, so in this chicken house is filled by the dust attached with a virus. So it's causes animal diseases. So right now, so we developed this this system to apply the chicken house gas treatment for the chicken house. Okay. And also, yes, we use this plasma for water treatment using like this one. And for example, yes, we generate the plasma inside the bubble like this one. And in this case, we put the glass tube in the water, and we put the high voltage electrode inside of the tube. And then we inject the gas to generate the like bubble. And when we apply the high voltage to the electrodes, it's like this plasma is generated inside of the water like that. And also we generate the plasma over water surface like this one. And we check how the plasma is developed on the like this one. Yes, this light size video is taken by the very, very high speed cameras. Okay, I will skip this one. Yeah. And also we generate the plasma in plasma underwater directly like this one. Especially when the plasma is generated, so cavitation is occurs, and very, very high strong. We can get a strong shock wave from these plasma generations. And also, so we have a collaboration with fine bubbles like this one. When we generate the plasma under water with the fine bubbles, yes, we can get a very high efficient plasma generations. Okay, so why we use plasma again? Okay, because the plasma generates a lot of the radicals, chemical species like hydroxy radicals underwater, and this hydroxy radical, because this hydroxy radical has a very high oxidation power, it can decompose like a chemical agent, chemical reagent, and it can kill the bacteria very easily. For example, this is one of the example to show the oxidation. Okay, so this when we generate plasma underwater, yes. So this blue color is decolorized by the plasma treatment, like this one. And in this case, so the main player show this blue color is like this chemical compound. And in here, so this chemical compound can be decomposed by the plasma treatment. To the finally CO2 and H2O. And usually we use this plasma for decomposition of the very toxic compounds like this one, and it can be decomposed by the plasma treatment very easily. And also we use this one for treatment of livestock wastewater, because yes, farmers feed this antibacterial agents to the animals like this one. But yes, so most of the parts is digested by the inside of the body of the animals. But yes, sometimes it cannot be digested and go out slow to the environment. And because yes, and this chemicals is very stable. So these chemicals cannot be decomposed by the traditional artificial mash systems. So these compounds go outside in the environment. And because these compounds has an antibacterial effect, so in the environment, so this one, it can kill the bacteria or microorganisms in the environment. So this is a very big environment problem. So in this case, we use this plasma to decompose these chemical, these agents, and it can be perfectly decomposed by the plasma treatment we checked. Also, so we use this plasma in water for the agricultural applications. And here, this is one of the example. Yes, we cultivate the spinach leaves like this one. And this line shows everyday students feed tap water here. But here, so we apply the plasma treated water here. And we apply these plasmas to the water. Yes, as you can see here, spinach can grow very, how to say, the spinach can grow very healthy and good well, like this. So this is because, yes, inside plasma, nitrogen gas can be changed the form to the nitrate, and nitrate can be dissolved into water, and it acts as a fertilizer of the plant, like this one. And in this case, so we can say the plasma can generate the fertilizer of the plant from the nitrogen molecule in gas, like this one. Yes, we try develop the plasma system to generate the fertilizer nitrate, and it can be instead of the Haber-Bosch process. Maybe everybody knows the Haber-Bosch. The Haber-Bosch is very famous for the mass production of the ammonia for the fertilizer of the food, but Haber-Bosch requires a high pressure methane gas, and the high pressure and high temperature is not good for ecology. But non-thermal plasma requires only nitrogen gas and H2O. And only, as I said, so this one can be generated by the only electricity. So in this case, so non-thermal plasma can be used as a fertilizer production process on site and on-demand processes. And also, yes, so this plasma treatment can contribute to inactivation of the bacteria. For example, yes, so when we cultivate the plant, like tomato plant, on the water contaminates the bacteria. Yes, so this plant can be infected by this bacteria, and most of them is weird, like this. But when we treat the water by the plasma, the most bacteria can be killed. And after that, so yes, plant can be grow healthy like that. So in this case, we can say yes. So this plasma treatment can use for the control of the environment or the plant cultivations. And also we have some pilot tests like this one in the farmland, and we can succeed to suppress the number of bacteria and grow healthy. Okay, so maybe so almost that is also my presentation. And yes, actually, so in our laboratory, we have totally 24 or 25 students like this one, and other with Professor Takahashi, like this. And yes, so we every day the students have an experiment and do their best. And if you have a chance, please visit my laboratory. And yes, I'm very welcome to you to visit, short visit, like several 1 or 2 months in my laboratory and to do collaboration experiment. Okay, and sorry, so maybe so there are many professors, some professors in this here. So let me have a short introduction about the new workshop. Yes, so we have a workshop called the Interdisciplinary Exchange Workshop for Future of All Asian Countries in IWATE 2025. And actually, so this the aim of this conference is to make new connections and friendships among young researchers from all Asian countries. And with every topic of researches like environment engineering and arts and physics and electrical and human society and everything are welcome. And yes, so we welcome the young and excellent world-class researchers from all Asian countries to have to get connections and to make a new collaboration researches. And actually, so this workshop is born in the last March in Korea. And we have this conference in the Thailand, in the Bangkok, Siam. Yes, Siam in Bangkok in Monday. And already we have this workshop in Chiang Mai in this May. But in the next year, so in the January, we have this workshop in the Taiwan, and then so we have this workshop in the IWATE, our university in the autumn season. And if you have, maybe there are some young researchers here, so please join us. But yes, so take it easy. So main purpose of this workshop is a drinking party, the drinking together and to get friendship. So if you have a chance, please join us. Okay, so yes, so that is all. Okay, so thank you very much. Okay.
Okay, thank you very much, Sensei. Really nice talk and very nice presentation, and also your PowerPoint is very nice. Yes. And you are growing up your research.
Yes, thank you.
Compared with last year, very much.
Thank you.
So it's time for the question, any question from the audience, especially from the student. Okay, first, Nima.
Yes, sir. First, thank you very much for your very nice presentation. It was very informative. I want to ask about the fertilizer treatment that you mentioned of the conversion of nitrogen component. So can you please explain a little bit more on how the plasma treatment influenced the bioactivity of this component on plants?
Like in this slide, it's okay?
Yes.
Okay. Actually, so yes, in this case, so plasma generates this nitrite ion through these reactions. The material to make this nitrite is a nitrogen molecule in gas phase, right? Okay. So actually, so this nitrite can be act as a fertilizer of the plant, and when we apply the nitrite ion solution to the plant, yes, because the plant plant knows this nitrate ion is a food for them, right? Fertilizer. Yes, so that's why. So it can be acted to the enhance the plant growth. Yes, that means that yes. So role of the plasma is making a fertilizer in this case.
Oh, I see. So this is the mechanism. And compared to the controlling, it's the fertilization is very high, right?
No. Yeah. It is a good point. Yes, actually, so in this case, so when we as a control is a tap water, no fertilizer. Yes. So when we apply the like a chemical fertilizer, yes, so it can grow near like this, similar like this. Yes. Do you understand that?
Yes, sir. Yes, sir. Yeah. Thank you very much.
Thank you.
Yeah. Beautiful.
Thank you. Thank you very much.
Thank you.
Thank you very much, Sensei. So the next question, please. Any question?
Every question is okay. So easy questions are also okay. What is this or something like that? Yes.
So I just have maybe one or two questions, very simple.
Yes.
What is the next step of your research?
Next step is so many next steps. Yes. So okay. So actually, so yes, we have some many applications, and some collaborator asked to me to make to develop this plasma system image. Okay, so we try to design the generator, and we check the performance in the practical use, and also yes, that is okay. And but to optimize this systems, yes, we have to know the mechanisms, fundamental research. Yes, like for example, so how this yes I show that like these reactions, but how can I optimize the like voltage and the electrical system to this fertilizer production? To know that, so we have to understand the mechanisms. Mechanism doesn't mean that like how is the temperature is the best, or how is the electron temperature is the best, or like this. And how is the speed, reaction speed, or like that. We have to understand that. So yes, actually, so like the base of the fundamental, and then so using that, using the knowledge of them, so we optimize and realize the systems. Yeah, that is like a next steps. There's so many steps. Yes.
Oh,
and for the application, so I'd like to conduct the application research, practical research in Thailand.
Okay.
Yes,
Thank you very much.
Yes,
so please come.
Of course, yes.
Hi, Sensei.
Hello.
I have a question. Hi.
Yes. Hi. Hello.
Yeah. Okay. Thank you for your presentation.
Yes, thank you.
Interesting. I have a question. If I want to treat wastewater from livestock farm with hydroxyl radical and hypochlorite acid,
Yes.
what kind of high voltage should I use, and can it precipitate the waste?
You mean what kind of the voltage is the best for protection?
Yes, suitable for live farm stuff.
Actually, yes. So it is how do I say very hard to answer that because it depends on the like electrode system and how much the volume or something like that. But actually, so maybe so I cannot say what is the best, but maybe you can keep the low voltage and the high frequency. Yes, because in this case, you can induce a lot of chemical reactions without heating up. Do you understand? Because in this case, I cannot say what's the kind of the voltage or what kind of the voltage is the best for the in your system. I cannot say, but I can say only this is never input a large energy in one pulse. That means in that case, maybe you should decrease the voltage, but on the other hand, you can increase the frequency.
Mm.
Yes. So in this case, maybe you can get a more high efficiency production of the hydroxy radicals. And also, so you can increase the number of electrons to avoid the constant compress of the hydroxy radicals. In this case, so yes, in this case, how to say, radical production efficiency can be decreased. Okay, like do you remember like a DVD, dielectric barrier discharges? Do you remember in my laboratory? No?
I
Yes,
remember.
yes, maybe like a DVD is one of the best, one of the good electrode system to generate the radicals. Okay. Anyway, so like a weak plasma with large volume is better to hydroxy radical productions.
Thank you.
Oh, thank you very much, Sensei. Oh no,
Thank you.
she went to your laboratory. She was in your laboratory.
Say 2 months? 2 months.
2 months. อ๋อหนูเคยไปอยู่ที่นู่นเหรอ
ใช่ค่ะ
2 months.
2 months.
2 months. Yes. She's a very
So,
nice student.
Thank you very
How
much.
about your feeling? How about your
Feeling.
feeling?
Oh, very good.
I would like to ask her. หนูลองอธิบายความเป็นอยู่แล้วก็เขาเรียกอะไรนะ ความรู้สึกที่ได้ไปที่ได้รับโอกาสได้ไปอะค่ะหรือจะเผื่อมีใครอยากไปต่อ
ภาษาไทย
เพราะ
ได้
เซ
ไหม
นเซ
คะ
เขาค่อนข้าง nice มากแล้วก็เขาก็เปิดโอกาส so
ค่ะ
Sensei, I would like
Yes.
to let her introduce about how she did and how can she go to Japan at your laboratory.
Up to Chatsai Sensei. Chatsai Sensei, yes.
หนูลองเล่าให้คนอื่นฟังหน่อยสิเป็นไงบ้าง เผื่อจะได้มีแรงกระตุ้นให้กับคนอื่นๆได้อยากไปเพราะเซนเซเขาค่อนข้างไนซ์เนอะครับผมเกิดเป็นประโยชน์
เซนเซค่อนข้างไนซ์มากค่ะ ก็คือหนูนะคะ
เสียงดังหน่อย
ค่ะหนูค่ะจากแลบอาจารย์ชัดชัยนะคะ ก็มีโอกาสได้ไปที่แลบค่ะไปแลกเปลี่ยนแล้วก็ไปคอนเฟอเรนซ์ที่ IWATE University นะคะก็แลบอาจารย์เป็นแลบที่ค่อนข้างจะใหญ่ค่ะแล้วก็นักศึกษาเยอะแล้วก็อาจารย์แต่ว่ามีงานที่หลากหลายค่ะที่เอาไปแอปพลิเคชันทั้งน้ำอากาศแล้วก็ฟาร์มในดินแบบพวกเกษตรเนี่ยค่ะค่อนข้างเยอะก็อาจารย์ก็ดูแลดีค่ะอาจารย์ไนท์มากค่ะแล้วก็บรรยากาศก็โอเคค่ะน่าอยู่ค่ะเป็นแบบธรรมชาติ
ไปเดือนไหนอ่ะ
หนูไปช่วงพฤษภากับมิถุนาค่ะช่วง
โอเค
ช่วง
ยังไม่หนาวเนอะ
ค่ะ
ยังไม่ค่อยหนาวเท่าไหร่
ใช่ค่ะ
ครับ
กำลังดีค่ะ แล้วก็ดอกไม้เยอะค่ะ แล้วก็ช่วงปลายเดือนเมษาค่ะ หนูไปทันปลายเดือน ซึ่งหิมะยังมีอยู่ค่ะ บนภูเขาอาจารย์ก็พาไปดูหิมะข้างบนด้วยค่ะสวยมาก
อ๋อไอ้ที่กำแพงหิมะใช่ไหม
ใช่ค่ะที่ฮาจิมันไตอะค่ะฮาจิมันไต mountain
Okay. Thank you very much for your taking care of her, Sensei.
Of course, yeah, of course. I'm very welcome for every student from your university, of course. Yes.
So any question? มีคำถามเพิ่มเติมไหมครับ ถามได้เลยนักศึกษาผมว่าเป็นโอกาสที่ดีนะเพราะเซนเซหายากนะครับ ที่จะเจอเซนเซแบบนี้นะครับ แล้วก็อนาคตโปรเฟสเซอร์แน่นอนครับแบบใหญ่ขนาดนี้เผื่อได้มีโอกาสนะก็เป็นการประยุกต์ใช้นอกเหนือจากที่เราเรียนทางด้านวิศวกรรมไฟฟ้าหรือวิศวกรรมอย่างอื่นนะครับแกประยุกต์ใช้ทั้งวิศวกรรมไฟฟ้าเคมีวัสดุแล้วก็ไปประยุกต์ใช้ทางด้านการเกษตรหลากหลายอย่างทางด้านอุตสาหกรรมทางด้านไม่รู้จะพูดไงเพียบเลยผม ผมว่าน่าจะเป็นตัวอย่างที่ดีนอกเหนือจากที่เราเคยคุ้นชินแล้วกันเคยคุ้นชินว่าสมมุติทำไฟฟ้าก็ต้องอยู่ไฟฟ้าทำพลังงานก็ต้องอยู่แต่พลังงาน อันนี้เขาเรียกข้ามศาสตร์ข้ามสายเนาะช่วยให้เกิดแอปพลิเคชันใหม่ๆหรือเกิดการประยุกต์ใช้ใหม่ๆได้ครับ
ผมมีคำถามหน่อยผมจะเกียรตินะ
โอเคเลยเชิญเลยครับ
Sensei, I have a question on the application for the greenhouse gas fightings for those the two application on the about the energy for the thermal high energy use for the plasma. That's the first application, and the second application about the capture of the dust. Is it possible for the PM 2.5 also for those two applications? One is the thermal application because of in the industry they are using the gas for heating all the especially for the steel industry that they require a lot of heating. Can it be used replace all those process that require the combustion process? And the second application that I mentioned about the PM 2.5, which is very concerned in Thailand during the winter season. There has a lot of this very small dust.
Okay, so sorry. So second question is a very easy to use that. Easy to use. So this correction is called the electrostatic precipitator. And so many industry factory use these techniques to remove the PM 2.5, and also this technique can be used for the build inside of building, like a room or a home. Is everything okay? Maybe it can be and how to say the electrical consumption is very low, so maybe you can use it very efficient method to eliminate PM 2.5. Very easy to eliminate. And sorry, so first question is application. Is okay. Second one is okay. Sorry, first question is for two more.
Thermal, yes, thermal for the steel industry. They require thermal energy. Thermal energy.
Yeah.
Thermal energy.
Thermal. Yes. Sorry, thermal energy for
the steel industry.
A steel industry.
Yes.
Like that means the increasing energy, increasing heating up or something like that.
Yeah, heating application.
I see. Actually, yes. So when we increasing high temperature, it is the opposite with the non-thermal. This is a thermal plasma. Yes, you can use it for the melting or something like that by heating up the plasma. Yes, in this case, it can be used for the melt the steel and everything. And it's like a summer, we can say summer plasma. And some professors is researching about that, and it can be used for the, yes, also, as you said, it can be used for the heating and melting steels and metals. Yes. But I'm not sure it can be instead of the as a way like a firepower or something like that. I'm not sure, but yeah, some guys is very says is very useful for the melting the steel metals. Yes.
Yes. In this application, they are like induction kernel. They are using the electrical energy.
Yes.
To heat the chamber that chamber will melt all the metal. So can we replace the current technology with the wire instead of using a plasma, something like
Yes.
that technology.
Yes. Yeah. Maybe
Can
I'm
it
not sure.
do-
I'm not sure, but induction is a much higher efficiency, I think, to just for heating up. of the
Yeah,
metal.
they use the induction
Yes.
furnace. They use
Yes.
electric to heat all the chamber, and then that chamber will melt the steel. But
Yes,
I
yes.
believe that just this technology can replace the current one or not, because they require less energy to produce high thermal, something like that.
Because it is
High
concentrated.
heat, something like
Yeah, yes, it's concentrated at localized, maybe. Okay, but actually, so I'm not familiar in the thermal plasma, but I have many friends regarding to the heating up and the thermal plasma. So I will ask to him to answer your questions. Yes.
that. Oh, I see. Okay, the plasma is good for the local, very local and very small
Okay.
portion. Yeah, I see.
Yes, yes.
Okay. Not a large surface. Okay.
Yeah.
Thank you.
Thank you.
That's it for me. Okay. Thank you very much.
Okay, thank you very much. Any question from the audience? Student? Any question?
มีคำถามครับอาจารย์
เอาเลยเชิญเลยครับ
ครับ Hi Sensei.
Hello.
I have question. I'm not sure about slide number. I interesting the hydroxyl radical. I want to know how to confirm the hydroxyl radical generation and how to maintain hydroxyl radical in your system.
Very, very good questions. Okay, so we check like the light emission at once. So light emission from the plasma, because so this is spectrum from the light emission from the plasma, right? And we can this like a 308 nanometer peak corresponds to the hydroxylogical excitation states of the hydroxylogical generated by the plasma. And we can check this peak. We can check how hydroxylogical is generated inside the plasma using this light emission, this peak. Can you understand this? Is okay?
Yeah, I see.
Yes. Okay, so sometimes we check this one with like light emission analysis of the spectrum. Yes.
By using UV visible light, right?
This one is a UV.
Yeah. Okay.
UV spectrometer. Okay.
I see.
For example, so this photo shows this left one shows taken by the normal camera. No, high speed normal camera, and this one we use a bandpass filter, drawing the 300 to the 320 nanometer. Yes, when we use this bandpass filter, only this window can be observed, right? So, okay, so you can see here. So this photo, this light emission is made by the plasma, like this. Okay, but yes, it's total. It contains the total of the every spectrum. But in this case, only hydroxylogical light emission can be observed. Okay, so that in that case, we can check where hydroxylogical is generated from these photo images. And also, yes, it's okay. First question is okay.
Yeah.
Your first question, yeah. And second one is actually, yes, your question is very good point. You point out it's a very good point. Okay, so this hydroxylogical is generated by plasma, but the lifetime is very short, especially for the in gas phase. It's around the lifetime is around several tens microseconds in gas phase. And
do you know
phase,
how many seconds? Do you know?
Several
microsecond.
Yes, several microseconds over, right? And underwater, that's lifetime is only nanoseconds, several nanoseconds. Okay, so it's very, very short. Yeah, it's very short. So yes, so second question, how to maintain to supply the hydrogen, right? And the answer is yes. So yes, when we generate pulse plasma, okay, so radical is generated and diffused. Okay.
I see.
So yes, within the microsecond, very short time. So in this case, to keep the supply the radicals, yes, we have to generate many times in the pulse, like many times. And then we generate like a short-time reactions, like that. Okay, usually we use like several thousand pulses per 1 second we generate, usually.
Okay.
So
Thank
in
you
this
so
case,
much.
yes, we can maintain to supply the radicals.
Yeah.
Good. Yeah, good question. Thank you.
Yeah. Thank you so much.
Thank you.
Okay, any question?
Oh, hi, how are you? Looks fine. Oh, hi. Sorry, maybe I cannot hear your voice. Maybe
Sorry. Okay. Okay. Hi, Sensei.
Hi, hello, how are you?
Okay, I'm fine. And you?
Yeah, very nice. Thank you. Thank you.
Yeah. When you apply the plasma with agriculture or wastewater treatment, I would like to know what are the costs regarding and the cost of electricity cost.
Sorry, again, please. Cost of electricity for.
What are the costs regarding cost and electricity? The cost when you apply the system plasma. Yes.
Facility. The cost of the device. I see. It depends on the volume treatment. The what size? What kind of size do you imagine in this case? Like a very big one, like this, or like a desktop?
I think a lab scale.
Lab scale. Okay. Lab scale is for example. So when we purchase like okay. Sorry, I don't have a photo, but okay. So when we purchase the pulse generator, one of that is cost is around less than 2 million Japanese yen. Can you calculate? Moment.
Oh, this one about 2 million
yes,
Japanese yen?
Yeah, for example, when we purchase like
ประมาณ 500,000 หาร 4 ครับ
4 million baht.
2 million yen?
Yes.
Oh, so about 5.
No, 0.4 million. Yes.
Yes. Okay.
Yes.
Yeah. Okay. Thank you.
Like 5,000. No, for 500,000 baht.
Yes.
0.5. When we purchase the generator.
Okay.
But it depends on the business. Like for example, so when we build on small compact generator, we can make it less than 100,000 yen. That means
okay. I think
20,000 baht. Yeah, like that. Several tens thousands baht. We can make it.
Okay.
Yes.
Good.
And not so expensive. Yes. Yeah, it depends on that. Like, how do we have a production? How do we have a marketing and business style? It depends on that.
Yes. Okay. Thank you very much. Now it's time maybe for your lunch.
Yes. Thank you.
Already have lunch. Sorry for the late lunch.
It's okay. No problem. Of course, no problem. Yes.
So now today on behalf of Faculty of Engineering and also the course of Energy and Materials Engineering.
Yes,
So
very
we
good.
would like to say many thanks to Takahashi Sensei,
Yes.
Takahashi Sensei, and not only for Sensei but also our friends, very close friends.
Yes, yes, yes. You're right.
So-
Yes, thank you.
So today's we would like to say thank you very much for
Thank
your
Thank
your
you.
presentation, very nice and many answer. And
Thank you.
for our student also in IWATE.
Yes, yes, yes. Of course, I'm very welcome everyone to IWATE. Yes, please come to visit my IWATE, my laboratory.
Yes. I would like to go again.
Yes.
Okay. So today, thank you very much, Sensei. Domo okini.
Thank you. ありがとう。ありがとう。
Domo okini. ขอบคุณนักศึกษาทุกท่านครับ ก็หวังเป็นอย่างยิ่งว่าวันนี้จะได้รับความรู้นะครับ จากเซนเซนะครับ เซนเซแกไนซ์มากหายาก
Thank you.
โอเค thank you very much เซนเซบายบาย
Bye. ありがとう。
Have a good day.
Domo.
Bye.